Good afternoon, my name is Asif Matadar and the title of my talk is Investigating WSL Endpoints. I'm the Director of Endpoint Detection and Response at Tanium. I've worked in InfoSec for over a decade and specifically incident response and penetration testing for over 9 years, leading high-profile cases around the world, such as advanced targeted attacks, nation-state attacks, and data breaches. I'm an international public speaker where I've spoken at industry-recognized conferences in relation to innovative research I've encountered. My research areas are in memory analysis and automation, NICS-based forensics, cloud forensics, and triage analysis. Windows Subsystem for Linux was announced back in 2016, and ever since then, the industry has been taking advantage of what WSL has to offer. What does that mean for someone who works as a digital forensics and incident response professional? Well, adversaries and malware authors have already started focusing their attention on WSL, so it is important to understand the architecture changes. This talk will highlight the nuances from a digital forensics and incident response perspective and identify the various attack surfaces an adversary can leverage, and when the need arises, the forensic artifacts of interest on a WSL endpoint. This is the agenda for the talk. I'll discuss what WSL2 is. What does that mean for digital forensics and incident response professionals? Then I'll highlight the 9 techniques that I discovered from an adversarial perspective and the forensic artifacts to keep in mind. What is WSL2? There's a full system called Compatibility, which means that WSL2 has its own customized kernel specifically for WSL2, so apps such as Docker are now supported. Whereas WSL1 had a translation layer to interpret system calls that allows them to work on the Windows NT kernel. This is challenging to implement all the system calls for Linux binaries, especially for long-term support. Compared to WSL1, it is much faster. WSL2 also has support for raw sockets. It's a new architecture for Windows Subsystem for Linux to run ELF64 Linux binaries on Windows. An in-house kernel developed from stable branch at kernel.org. Customized kernel specifically for WSL2, which is optimized for size and performance. Kernel updates will be surfaced by Windows Updates. Lightweight utility VM, which is not a traditional virtual machine. It's a thin version of a Hyper-V hypervisor, so faster boot times compared to traditional virtual machines with no virtual machine configuration or management. Something to note here is that the hypervisor is similar to what is used by the Windows sandbox. So Linux and Windows share the same timers, which means that Linux files can be hosted in a virtual disk with a Linux native exe4 file system using the 9p protocol to interact with Windows and Linux. What does that mean for digital forensics and incident response professionals? As mentioned, WSL2 has its own customized kernel specifically for WSL2. The exe4 virtual disk is on the NTFS file system in user's app data local packages folder with the corresponding reference to the instance name, in this example, Canonical Group Limited, which is Ubuntu. Management of WSL can be used to interact with WSL Hyper-V VMs. You can import and export distributions. You can set default distributions. You can also specify what version to run, so if you want to run version 1 or version 2. Environment variables are used on WSL2 endpoints pertaining to the bash environment and the WSL environment variable that is used by the Hyper-V VMs. Every app that you download creates the Windows Apps folder in C Program Files Windows Apps, which is a protected folder that is hidden. Within the Windows Apps folder, each subsequent app has its own dedicated subfolder, and here you can see the Ubuntu binary, which when run will start the WSL2 Hyper-V. The other location is in the user's app data local folder, where there'll be a Windows app folder with subfolders related to the designated Windows apps. Here you can see the Ubuntu binary in the user's app data local folder. Now I'll discuss the 9 techniques and the attack surface that an adversary can leverage when analyzing the WSL endpoint from a forensics perspective. This is the environment that was used, so Windows 10 Pro, version 2004, OS build is 19041.84. These are the experiments that were run, and the premise being that the adversary has a foothold on the WSL endpoint, then leveraging the attack surface. I'm going to demonstrate the different attack surfaces from an adversarial perspective and the forensic artifacts to be aware of. The first technique is related to persistence using bashrc. As mentioned earlier, the environment variables for the bash environment and the WSL environment variables are used on WSL2 endpoints, as is evident in the registry editor here. This is important to highlight because we will be making amendments of a bash environment for this persistence technique to work. In this example, we have a bashrc file appended with an awk reverse shell and the listener from the attacker perspective confirming that the shell was received and it was indeed the customized kernel version of 4.19.84 developed by Microsoft. Something to note here is that after each time the WSL2 Hyper-V is started, the persistence technique will run. From an analysis perspective on the WSL2 Hyper-V, it is important to trace the MAC times and data contents of a bashrc file along with the bash or shell history, including the inodes from a timeline perspective. There are a number of process execution artifacts to keep in mind of a host Windows 10 machine. The amcache file is a registry file that stores information of executed applications. That includes the execution path, the first installation time, and the first executed time. It was evident that the amcache program entries along with the amcache associated file entries can be traced. The application compatibility database is used to identify application compatibility issues. So the shims allows backwards and forwards compatibility for applications on different software platforms. As is illustrated, the application compatibility database showed artifacts where the Ubuntu binary file was executed. Another useful artifact is the user assist that contains information pertaining to links and applications used frequently with a count and last modified time. In this example, it is possible to ascertain how frequently the WSL2 Hyper-V has been used along with the last modified time. The prefetch file is used for optimizing the load time for the application for performance reasons, which can be used to ascertain when a binary or application was last executed along with how many times. The Ubuntu binary was identified as being executed. The MFT is a database in which information about every file and folder is stored on NTFS. Parsing the MFT showed traces of a virtual hard disk and the location of a Ubuntu binary. Moving on from there, this technique is what I like to refer as persistence through inception using systemd. The first stage of this technique was that a file was created in the var temporary directory, which was a socat reverse shell to the attacker infrastructure, then enabling and starting the systemd service. The adversary was able to receive the shell and confirm that it indeed was a Ubuntu WSL2 Hyper-V, which is the customized kernel version of 4.19.84. The second stage of this technique was that an entry into the current version run key was included, with the entry being the Ubuntu binary. After each reboot of a Windows 10 host machine, the persistence was successfully loaded and the WSL2 Hyper-V would establish a socat reverse shell. From an analysis perspective, analyzing the systemd journals along with the systemd configuration files can provide useful information to an investigator. The registry artifacts for any persistence techniques is also recommended. The shellbag's registry keys stores user preferences for GUI folder display within Windows Explorer. Any user activity on Windows Explorer that were opened and closed can be traced with the shellbag's registry key. First and last interacted times are quite useful to observe. So if an adversary has browsed specific directories in the UNC for the WSL Hyper-V, then the shellbag registry key can provide indications of such activity as this screenshot demonstrates. This technique is related to execution of Powershell. Running Powershell scripts is another technique that is possible on WSL2 endpoints. In this example, execution of a Powershell script to make a call to the attacker infrastructure and the shell was received, and confirming by running getAlias Powershell commandlet to retrieve the aliases from a current Powershell session. From an analysis perspective, analyzing the bash history, the shell history, and undergoing timeline analysis for the inodes is recommended. Looking at unusual Powershell processes that have established an outbound communication should also be observed. The next technique is execution of Python by downloading a file. It is possible to download a file using Python and confirm that the file has been downloaded. This screenshot illustrates this activity. From an analysis perspective, analyzing the bash history, shell history, and undergoing timeline analysis with the inodes is recommended. This technique is downloading a file in Python, but how network traces can be used to extract such files. So you enable network traces by running netsh trace start with a packet filtering capability capture and the source or destination IP address. You can see the file being downloaded using Python. When you stop tracing an event trace log, an ETL file is created. You can convert the network frames from the ETL file into a pcap-ng file to be analyzed with Wireshark, TCPdump, or tshock. In this example, the Python file that was downloaded with a HTTP GET request and the user agent is apparent. You can export the HTTP objects and save a file as highlighted here. This technique is going to be similar in nature, but will establish a SOCAT reverse shell and use network traces to analyze the packets. So we start the network traces. After the network traces were started, a SOCAT reverse shell was established to the attacker infrastructure with the adversary acknowledging the shell. We stop the network traces. Once the ETL file is converted into a pcap-ng file, you can see that the SOCAT reverse shell was established along with the attacker infrastructure IP address, the destination port, and the error suggesting that the TTY cannot be accessed. The adversary then ran uname-a, and the output of that is evident here. This technique is in relation to execution of a WSL binary, where it is used to interact with the WSL Hyper-V VMs and setting default distributions, but an adversary can use the exec option to execute arbitrary Linux commands. This example shows the exec option being used and running cat against the etc os release file to retrieve a version of Linux. This example shows the exec option being used and downloading an arbitrary file on the file system. This is another example of an exec option being used, but this time to pipe commands. So to tar the file and pipe that into an SSH session without touching the known host file. It is clear that the known host file was not touched and the file was exfiltrated to the attacker infrastructure. From an analysis perspective, it's important to analyze any process command line activity and process lineage, especially in relation to the WSL binary. There is one caveat here in that the Linux command will not be saved in bash or shell history, etc. So it's very important to determine the above 2 points in relation to analyzing this technique. This technique is in relation to execution of a bash binary. The bash binary is located in C Windows System 32 on a WSL endpoint. This is an illustration of the execution of a bash command with OpenSSL to download an arbitrary file from the attacker infrastructure. From an analysis perspective, analyzing the process command line, execution of a bash binary, and outbound communication should be something to look out for. Finally, execution of a curl command. This example shows that the curl command was used to exfiltrate a file to the attacker infrastructure with a socat listener, and it was possible for the file to be exfiltrated successfully. From an analysis perspective, analyzing the process command line, execution of a curl binary, and outbound and inbound communication should be observed. To conclude, adversaries will continue to explore attack surfaces on WSL2 endpoints. WSL2 endpoints is going to make digital forensics and incident response professionals' lives interesting, to say the least. I've highlighted 9 techniques based on my initial research, but I expect more techniques will be uncovered in the coming months and years as WSL2 becomes more prevalent. These are the references I used in this talk. Thank you for attending my talk, and I'd be happy to answer any questions.